So good afternoon. My name is Chris Agbove, and today I'm going to be taking you through some simple catching techniques. We're going to talk about various methods in catching, types of catching, and then what some tools that are using what catching. Okay, so let's look at what our question right here. What is catching? Okay, when I'm referring to catching, I'm talking about the word catch. C-A-C-H-E, catch. I know you've been saying it on what your phones, what your laptops, every kind of device that you've been using, they all have what cache memories. Okay, and then the cache memory basically what stores what, should I say info or data? Yeah, both info and data what temporarily. Okay, they store it temporarily to be reused or reaccessed. You get that right? So now let's look at this. Caching is a what critical performance optimization technique used across computing what systems to store what frequently access data in what fast access storage layers. As I said, it stores what info or what data temporarily, and it can be what reused. I talked about that. Let's look at what some fundamental what concepts in what catching. Okay, so let's take our first hit. Catch it, catch it. Okay, let's talk about catch it. What's catch it? Let's take a look at this scenario. When you ask for data, and then it's already in the cache, like you requesting for data, then you receive it what the moment you request for the data. So right here it say what one requested data is found in the cache. Okay, so let's take a look at two cache miss. Data isn't in what in cache, so the system has to go what the long way to get it. Okay, there isn't data in the cache, and the system has to what do a lot of processes and what steps in order to get that data you're looking for. Okay. Now let's look at hit ratio. Hit ratio simply means what? How often you get catch hits versus what misses, which is also known as what high equals good or what higher is what better. The higher it is, the better it is. Okay. Now for catch invalidation. Catch invalidation simply means what? Getting rid of what outdated data in what the catch, so you don't what save still junk. Okay, you're getting rid of what outdated what data in the cache, or what old data in the cache. You're getting rid of them so that what your cache doesn't have any kind of what junk. When I say junk, I say baller. Yeah, let me just say it in Ghanaian language for you, baller in the cache or something. Okay, so now let's look at what cache placement techniques or what strategies. The first one here is what browser caching. Okay, and you are talking about HTTP caching headers. It is also under the HTTP caching headers. We have what cache control, e-tags, expires, and what last modified. And here are some examples: memory cache into bracket fast but volatile, and we have what the disk cache, which is also what persistent but what slower. Okay, so we are talking about the browser cache. And browsers what store full stuffs or store stuffs like what images, scripts, pages using headers like cache control and e tags. Okay, so the browser simply does all of those things. Okay, it stores all those images and what pages when you're just what simply using it. Let's take a look at what two CDN caching. Okay, and in other words, content what delivery networks caching. Okay, this this store files on what edge servers near users. Okay, it just simply stores what files on edge servers. As you can see there, it says what edge servers cache static content closer to what users. So it's storing your cache on what edge servers that are what closer to users or what popular providers. Okay, and it's that simply helps what your what should I say your website loads what faster globally. Yeah, it helps your website also load very faster. Now let's look at the third one. We have what application level caching. Okay, application level caching. This simply means what your apps hold data in your RAM. Okay, like a variable. Yeah, it holds what data in your RAM. So it doesn't what recalculate or what refetch it constantly. Okay, doesn't recalculate or read fetch what that same exact type of what data that's been stored in your RAM. Doesn't save or what recalculate it what constantly. Okay, just a one-time thing. That's what it does. Let's look at for distributed caching. Distributed caching is what a shared what memory across what multiple servers using tools. Okay, we're going to talk about the tools very soon. The tools are here. We have what Redis, Memcached, and what Hazelcast. Okay, let's look at 5. The database what caching. A query results what caching buffer pools for frequently accessed data. Okay, okay. Now let's move to our next one. We have what advanced what caching what techniques. Okay, we're going to be talking about advanced caching techniques. Whilst we were talking about what the basic caching techniques, we're going to be talking about the advanced ones also. Okay, keep that in mind. Let's look at the first one. The first one we have there is what cache warming. Okay, preloading the cache what before the system goes live. To avoid what cold start, as you can see there, import performance issues. You preload your cache before what the system goes live or the system comes what to life to prevent what cold start and prevent performance issues. Sorry. 2. Cache sharding. You have what partitioning what or splitting what the cache across what multiple servers, and what it helps what improves scalability and what reduces what contention. Okay, so this simply means that so no single node what gets overwhelmed or something related to it. Okay, so now we have what 3 multi-level what caching. A hierarchical what cache layers. We have L1, L2, and L3. Some examples are what CPU caches, RAM, and SSD. Those are what the basic ones that we know. Okay, so 4 cache aside or what lazy loading. Cache what aside. So that what application checks cache first, loads from what your DB in what mess. On mess rather. Excuse me on that. Most common pattern involves what web applications. Okay, so let's look at 5. The read through what cache. Cache automatically loads from what your DB on mess, simplifies what application logic. So the cache automatically loads from your DB. Let's go. We're going to look at what our next one that we have here. We're going to look at what some cache strategies. Okay, some strategies on cache. Okay, excuse me. Time based. Let's look at this. We have the first one out there. We have is what time based expiration. That's what set fixed TCLs for cache entries. And we are saying it's what simple but may serve what a stale data. Okay, time based. We are talking about time based expiration. Simply was it set expiry timers on what every cache that is what's being entered. So let's take a look at the 2. You have what event based invalidation. Invalidate cache when source what data changes. We are saying more precise but complex, and what complex to implement. Okay, it's more precise but complex to what implement. It means that what it can't be what, like, how am I going to say it? It can be what implemented, like recopied by what should I say? It can be recopied. Yeah, it can be recalculated and recopied. That's what I'm trying to say. Sorry. So 3 versioning on what target. Okay, version. Our version identifies to cache keys, which what invalidates by what version rather than what individual items. Okay, use version numbers on what cache keys. It's easy to what control what updates. When you use version numbers on cache keys, it's going to be really easy to what control cache what updates. Okay, so 4 write invalidates. It's going to write invalidate. Sorry, invalidate cache entries on what write operations. Okay, and we are saying it what ensures fresh reads after what write. Yeah, just simply what it wipes the cache after every sorry wipe cache after what every write. Okay, let's take a look at our next one. We're going to talk about some what example of what Caching tools. Some example of caching tools. The tools that are mostly what used in what catching. Sorry, example of catching tools. Okay, so let's take a look at the first one. Redis. What does the Redis do? It supports what? Advanced data structures. Okay, supports advanced what? Data structures. Thank you. Let's take a look at the second one. Vanish. What does the Vanish do? It's a what? Hypertext what? Transmission protocol as accelerator for what? Web content. Simply means it accelerates everything that's literally related to what? Web content. Okay, you browsing on what? Or should I say you browsing, or should I say you researching using the web? The Vanish what helps what? Accelerates what? The web's efficiency. Okay, let's look at the Memcached. Okay, Memcached, a simple high performance key value store. Okay, let's look at 4, the CDNs. Excuse me, sorry for that. Or into brackets what? Cloudflare, or also known as what? The AKAMI, AKMI. So the cache statics affects what? Globally. Okay, so let's look at what some simple what importance of what? Caching. Okay, we're going to take a look at the first one, which we have there is what? Performance what? Optimization. Performance optimization. And when we are talking about performance optimization, we're talking about what? How what, like, it helps what? Reduces what? Latency when retrieving data from the RAM. Okay, so let's take for instance, if your RAM is 10, let's just say 10 times slower or something, you what? Properly using the method of caching can increase that what? Performance or what? Of the cache to what? Let's just say 100 times to 1,000 times better. Okay, and on that same point, yeah, what? It improves what? Responses times. Okay, you it improves what? Responses times. So let's take a look at 2, cost and efficiency. Yeah, why are we talking about cost and efficiency? Because what? It helps lowers what? Infrastructure costs. Okay, this simply means that what? There are going to be what? Fewer servers that are going to be what? Needed. Means what? Instead of you buying around, let's just say, or using around 30 servers, you're going to be using around 15 or 10. Okay, and it reduces the bandwidth uses. I say bandwidth, the bandwidth uses also. Okay, the bandwidth usage. Yes, the bandwidth uses is literally, like, bro, it's literally what? Related to what? Data transfer. Okay, related to what? Data transfers. Let's talk about 3, and has what? User experience. Okay, this simply means it speeds up what? Anything you're using your browsers for. Your browsing. If I'm saying browsing, I'm talking about what? You searching, like going doing research online. I'm not talking about the browsing. Okay, you doing researches online. It helps what? Speed up what? Your research when you're using a web browser. Okay, and it helps what? Smoothing what? Your app's performance on what? Your device. Okay, it helps what? Smoothens what? Your app's performance on your device. Okay, and let's talk about 4, scalability and what? Throughput. Sorry, scalability and what? Throughput. Scalability and throughput. You're just going to be saying that what? It reduces the what?